Hello guys, welcome once again to another presentation about functional groups. We'll start by defining what a homologous series is. A homologous series is a series of compounds with the same functional group, each different from each other by a CH2. It can also be defined as a family of compounds containing the same functional group. This is the most simplified definition of a homologous series, where it's a family of compounds containing the same functional. What is a functional group? It is a group of atoms that determine the chemical properties of a homologous series. It determines the chemical properties of a homologous series, which means a functional group determines the reactivity of a certain homologous series. As for our functional groups, here I've made a table. Now, this column, the first column represents the homologous series, and the second column, the functional group, the third column, the prefix, and the fourth column here is for an example for each homologous series. As for the first homologous series, we've got our alkanes, and the functional group for our alkanes is the CC single bond. Here, the CC single bond, with our prefix being ANE, N. As for example, ethane. This is ethane because it has got two carbon atoms. It automatically becomes ethane. It ends with an ANE. As for our next homologous series, we've got our alkenes, and the functional group is denoted by a CC double bond. As you can see here, these two carbon atoms are joined together by this double bond, and the prefix is ENE, in, as in our example, ethene. The third functional group, we've got our alkynes, denoted by the CC triple bond, and the prefix YNE. It simply becomes ethine. This is the structure of ethine with two carbon atoms. The next homologous series are our aldehydes. These are the compounds, the first compounds that we have here with the carboxyl group, and this is the basic structure of an aldehyde, where we have got the R representing a hydrocarbon chain bonded to this carboxyl group, and the prefix automatically becomes now. And as for this example, this is ethanol, depending on your pronunciation, ethanol. And the next homologous series that we have are our alcohols, denoted by this functional group, which is an ROH, and R representing a hydrocarbon chain, and the OH denotes the functional group. And the prefix for this particular functional group, as you could guess, becomes O. And this example is ethanol. As you can see there, we have got our ethane bonded there with an OH, and it automatically becomes ethanol. And this one, we have got the next, which is ketones, our ketones, and this one represents the functional group of a ketone with two R's sandwiching this carboxyl group, and it automatically becomes a ketone with an ONE prefix, and this one automatically becomes propanol. Since it has got three carbon atoms, 1, 2, 3, it becomes propanol. Our next homologous series are our esters. Esters with an RCOOR. RCOOR. This compound is made by joining an alcohol and a carboxylic group, which were carboxylic acid. Sorry, it's a carboxylic acid. And this first component comes from the alcohol, and this last component comes from the carboxylic acid, such that, as in our example, the compound that we have is ethyl ethanoate, meaning the ethyl part comes from this part, which comes from our ethanol, our alcohol, and this one comes from our carboxylic acid. So the compound becomes ethyl ethanoate, and the prefix is oate, O-A-T-E, oate, O-A-T-E. Our next homologous series that we have got our amines with the functional group RNH2, and the prefix automatically becomes amine. And as for our example, we have got propylamine. This is propylamine with 3 carbon atoms, as you can see, 1, 2, 3, and then an NH2 at the end. So this is a primary amine, since the nitrogen is bonded to 2 hydrogens. But if we could introduce another hydrocarbon chain on one of the hydrogens, then that would be a different story. It would become maybe a secondary amine if we removed 1 hydrogen. But if the 2 of the hydrogens were removed, then it would become a tertiary amine. But as for instance, we've got propylamine, which is a primary amine. And our next homologous series are our ethers. And we've got these oxygen atoms, which is bonded here to 2 hydrocarbon chains to form an ether, and the prefix for this particular functional group is the ox. So as in our example here, we've got diethyl ether. Our next homologous series here, we've got our arenes, denoted by this, a benzene ring, and this automatically, the benzene becomes the prefix for this particular homologous series. And our example here, we've got methyl benzene. As you can see, there is our other group bonded to this benzene ring. It automatically becomes methyl benzene. And our next homologous series are our amides, where we have got this carboxyl group bonded to a nitrogen there, and this linkage forms our amide. Wherever you see this linkage on hydrocarbon chains, then you will know we have got our amide, and there is the prefix for our amides, IDE. It automatically becomes our amide, as you can see there. It becomes ethanamide, since we've got 2 carbon atoms, so we've got ethanamide. And then this brings us to our other homologous series of phenols. This is quite interesting, where we've got our benzene ring now bonded to our OH, which is the functional group for alcohols, to form a phenol. So whenever you see an OH, this alcohol functional group bonded to a benzene ring, you know it automatically becomes a phenol. And as with alcohols, the prefix there automatically becomes our OL, O, to mean O. And then there we have got phenol. This brings us to our next homologous series, which are our amino acids. Amino acids. The functional group for our amino acids is here, which is denoted by this alpha carbon bonded to our amine group and also our carboxylic acid group, and then the R is the hydrocarbon chain. So all these add up to form the amino acid functional group. And as for example, we've got here amino ethanolic acid. Amino ethanolic acid. So the amino part comes from this NH2 group, and the acid part comes from this COOH group. So the naming of these compounds is quite very, very important. If you get the name right of all these compounds, the organic compounds, working with them will be quite much easier. You have to check out my other video on naming of organic compounds. So we go on to our next homologous series, which are our acyl halide. Acyl halide, and there is the functional group for our acyl halides with our hydrocarbon chain bonded to our carboxyl group, as well as to the carbon bonded here to the halide. The X represents the halides, which could be fluorine, chlorine, bromine, and the prefix for this particular homologous series are our anoyl halide, and then the example there where we have got our ethanoyl chloride, since we've got two carbon atoms there, so it becomes ethanoyl chloride. Then our next homologous series becomes our halogenoalkanes. These are quite simple, where we've got the hydrocarbon chain, which is an alkane bonded to a halogen. This X denotes halogen, fluorine, chlorine, and bromine, and automatically this functional group has got a prefix of ane, which automatically, here is an example, we've got 2-chloropropane. If you don't know the naming or how we name these compounds, please check out my another video on nomenclature of organic compounds. Since the major functional group, this Cl, this is our functional group for our halogenoalkane, is on position 2. So we start naming from this position 2 to say 2-chloropropane. So our next homologous series are our carboxylic acid, denoted by the COOH group. The COOH group is bonded to a hydrocarbon chain. Then at the end we add a COOH group, and the prefix for this particular functional group is the oic. For here we have got propanoic acid. This is propanoic acid. Since we have got 3 carbon atoms, it automatically becomes propanoic acid. And our other functional group that we have are our nitriles, which are singled out by the hydrocarbon chain bonded to the CN group, where you've got a triple bond between carbon and nitrogen. So this RCN group denotes the functional group of our nitriles. And thank you. We've come to the